Okay, in section 2.4, we're going to take a look at absolute values in open sentences. First, our objectives are to interpret the absolute value as the distance between two given points, and second, to solve for the absolute value expressions in equations. Let's take a look at this table first, and think of absolute value of x as the distance between the graph of x and the origin on a number line. With that said, we can conclude the following. First, let's take a look at our first row here. When the absolute value of x is equal to 1, it simply means that x could take on the value of 1, or x could be negative 1. Again, because absolute value means the distance from 0, well, here's 0. What number is 1 away? Well, 1 is 1 unit away from 0, but negative 1 is also a distance of 1 unit from 0. So either x equals negative 1 or x equals 1, both of those points are a distance of 1 away from 0. This gap here is 1. This gap here is 1. Let's take a look at the second part to make more sense of this. This says, well, what about the absolute value is greater than 1? Well, that means that this number here is going to be a number like 2, or 3, or 4, or 5, or negative 2, or negative 3, or negative 4, or negative 5. So it's everything outside of 1 or negative 1 on the number line. Well, that just means that all we have to do is go to 1, but then it's everything beyond that on the number line. So 2, 3, 4. So it's an open circle here, just because it's greater than. If it were greater than or equal to, it would be a closed circle. So it's an open circle at 1, but it's everything that's bigger than 1. So we want the distance between here and a given point to be bigger than 1. So take, for example, here and 2. Well, that distance is 2. This distance between these two is 3, and then 4, and so forth. So any of these values is at least 1 unit away. Greater than 1 unit away. Everything here is also greater than 1 unit away, but it's greater than 1 unit away on the negative side of 0. So some people also have a tendency to think about the fact that you can recopy whatever this says here, and then you could flip the sign and negate it also to look at the other one. But the key is to notice that this becomes an or statement. Okay, so a greater than symbol, okay, assuming the absolute value is on the left-hand side here with the variable. If you have a greater than symbol, it's got to be a further gap than 1 unit away, so that's always going to end up being an or. Now with a less than unit, it means that what values of x would be true here, such that when you take the absolute value of it, it's less than 1. Well, a number like a half, or a quarter, or a negative half, or a negative quarter, or pretty much any decimal or 0. So what we do here is we realize that we want the distance between x and 0 to be less than 1. Well, x could be any of these quantities here, because if I pick x as this number, then here's my distance, it's a half. If I pick here, the distance is 0.75. If I pick a number here, the distance is 0.25. Pick this number here, that's about 0.6 away. So any of these quantities are close enough to 0 to be within 1 unit away. Now, this ends up being an AND statement, because really we have every number less than 1 and every number greater than or equal to negative 1. That's the overlapping of those two sets. So it turns out that when you have a absolute value here and a less than symbol, you end up getting an AND statement. An AND statement. And these are good points to notice because we'll use them a lot throughout this lesson. So the first example says solve the quantity absolute value 2x minus 4 equal to 14. Well, we have to remember that whatever's inside the absolute value could really be 14 or it could be negative 14. Again, this quantity here, that could be 14, giving us 14, or technically it could be negative 14, because when you take its absolute value, you'd still get 14. So we have to set what's inside of here equal to both cases. So we say that 2x minus 4 could be 14, or 2x minus 4 could be negative 14. Again, because the absolute value tells us that if you take the absolute value of that, I don't care about the negative or positive sign, but the distance from 0 is 14. But now we have to solve this. So we add 4 to both sides, we get 18, and then we get 9. Over here, add 4 to both sides, we get negative 10, which gives us negative 5. So this tells me that x could be 9, or x could be negative 5. So there are two possible solutions, and make sure you check your original, or you check your answers in the original statement. So make sure you go ahead and plug a 9 in up here and see that it's true. You'll get 14 equals 14. Plug the negative 5 in up there separately in another check, and you'll also see that it's true. Example 2 says solve absolute value of 6 minus 4u less than 5 and graph the solution set. So again, When it's less than, we're in our third case here from the table, which happens to be an AND statement. And in case you were confused about that, we could say, well, everything less than 5. Well, what does that mean? That means that 6 minus 4u has to be less than 5. And 6 minus 4u needs to be greater than negative 5. Again, what are we doing? In our mind, we're setting up an AND statement. And that AND statement, technically, in our mind right now, goes from negative 5 to 5. We're going to see in a moment that we're not really looking in this region. We're going to find an actual solution set. But that's what you're thinking about pictorially. This quantity, 6 minus 4u, is somewhere between negative 5 and 5. So let's go ahead and solve these. Solve them separately. So we have negative 4u less than negative 1. And here, we're going to get negative 4u greater than negative 11. Dividing by negative 4, we have to think about the fact that we're dividing by negative, so we have to flip the sign. So that becomes greater than. And then negative 1 over negative 4 is just a quarter, or 0.25. And here we're going to have to flip the sign also, so this is going to become less than. And 11 over 4 is approximately 2.75. So what does this tell me? This tells me the following. U is greater than a quarter, but it's less than 2 3/4. So if we had a solution for this, it would look like the following. U is in the set of numbers ranging from 0.25 all the way to 2.75. And on a number line, we would simply go ahead and plug in these values. 0.25, 2.75. We would say, well, U is in between them, not including them, so it's an open circle, and we connect them. Okay? You can check your answer region by testing any given point in there. So notice that the number 1 is between 0.25 and 2.75. So test the number 1 in the original equation to make sure that it works, and it does indeed end up being true. You end up getting 6 minus 4, which is 2, and 2 is indeed less than 5. Example 3 tells us that 3/2 is less than or equal to the absolute value of 2 plus a half x. And we want to solve this. So what this is really saying, if we think about it in the previous manner with our table, we're saying this. We're saying that this quantity here is bigger than or equal to 3/2. Well, when some quantity x in an absolute value is bigger than another number, it's going to be an OR statement. Okay, so we have to think about our OR statement from earlier. So what we have are two different parts here. Again, remember that these two, the direction was switched. Normally we had the x portion over here and the numerical portion, and that was equal to greater than or equal to, but if we read it from right to left, this indeed is greater than or equal to this quantity. So this is an OR statement if you go back to your table to check. So we have the following. We have 3/2 less than or equal to 2 plus 1/2 x, or 3/2, negative 3/2 rather, greater than or equal to 2 plus 1/2 x. Okay, again, solving it the same way as we did earlier. So let's go ahead and take a look. I would multiply everything by 2 to make this easier, yielding 3 less than or equal to 4 plus x, or negative 3 greater than or equal to 4 plus x. Subtracting 4 in the first equation, we're going to get x greater than or equal to negative 1, or on the right-hand side, subtracting 4, we're going to get x less than or equal to negative 7. Well, it's an OR statement, so we know that the direction is going to split, but clearly both of these can't be true. It's either or. So we think about our number line now. We say, well, here's negative 7, here's negative 1. X is everything less than or equal to negative 7, or everything greater than or equal to negative 1. So it looks just as we had expected. Again, an OR statement separated. If we wrote this as a solution set, it would look like the following. X in the set of numbers where x is less than or equal to negative 7, or x is greater than or equal to negative 1. And notice I have a tendency to write my answer as I see it on the number line. I saw this first, so I wrote x is less than negative 7, which is the same as this. And then I saw this, so I said x is greater than or equal to negative 1, which is what this is really. Example 4 says solve 2 times the absolute value of m plus 4 greater than 5 times absolute value of m minus 8. And the reason I'm doing this problem is to remember that absolute value of m can be treated like any other variable as long as you have like terms. So start by subtracting 2 absolute value of m from both sides. Yielding 4 greater than 3 absolute value of m minus 8. Add the 8 over to both sides, you're going to get 12 greater than 3 absolute value of m. Well, 3 is a multiplier on the outside, so divide by the 3. So you get 4 greater than absolute value of m. Well, when is m, in this case, if you read it from right to left, m less than 4? Well, m is less than 4 when it's 3, 2, 1, but the absolute value, so it could be negative 3, negative 2, negative 1. So pretty much we're saying that this has to be between negative 4 and 4. So our solution set is simple. You don't even have to break this up, really. All we do is this. Okay, that's our solution set. Because again, absolute value of m is less than 4. Tells us that m can take on any quantity as long as its numerical value is something less than 4. Now, again, we're looking really at the magnitude, so we know that numbers like negative 3, negative 2, negative 1, those also work, because when you take the absolute value, they're still less than 4. So our solution set for this would be m is the numbers between 4 and negative 4. So number 5 says solve 1 less than absolute value of 2 minus r, which is less than or equal to 2, in graph its solution. The thing we want to notice right away is that this is clearly an and statement because we have something in between here. So we have two things going on. Let's break them up just to see what that is. But what you'll notice next is actually that we have and or statements written together. On the left-hand side, we take a look at this. Whenever we see a greater than sign, and that's what this is really, even though it looks like less than because we're reading it this way, this quantity is greater than 1. That's an or statement. Again, greater than is an or. It's like on the outsides. So we could also look at this by saying, all right, well, 1 is less than 2 minus r, but negative 1 is greater than 2 minus r. But the or part is the tough part. You have to carry down the and. Over here it says it's less than or equal to 2. Well, whenever a quantity x, or r in this case, an absolute value is less than a number, it's an and statement. It's in between them. So here what we really have is that 2 minus r is less than or equal to 2, and 2 minus r is greater than or equal to negative 2. So what we have here is 4 different parts of the problem. Okay, it's this or statement and this and statement. So let's solve these each individually. Start over here, we'll work this one, then we'll work this one, then this one, then this one. First we can start by moving the 2 over by subtracting 2. And that's negative 1 less than negative r. Or, in this case, again subtract 2, negative 3 greater than negative r. Over here we're going to subtract the 2, we're going to get negative r less than or equal to 0. And when we subtract 2 on this side, we get negative r greater than or equal to negative 4. Continuing to solve, we have to remember to flip our signs of all these. So this becomes this. This becomes this. This next one becomes this. And the last one becomes this. So we know that r is greater than 1. We know that r is, let's start over here. R is less than 1. R is greater, or it's greater than 3. And r is greater than 0. And r is less than 4. So we have to graph these on a number line. Let's take a look. R less than 1, well, we're going to have 0, 1, 3, and 4 are some of our critical points here we have to focus on. So r less than 1 looks like this. Or r greater than 3 looks like this. So that's the solution to this part right here. That's what it's going to look like. But we also know that r is to be bigger than 0. This is an and statement here. So these things have to hold true. R has to be greater than 0. Well, this portion is not greater than 0. Everything bigger than that is greater than 0, so technically greater than or equal to 0. So technically we have to stop here with a closed circle, because that does not hold true to this part right here. In the next part, everything is less than or equal to 4, means that it has to stop at 4. So this portion is not really true, but everything else holds true. So our final answer is just these little regions, and I'll erase what's left over, what we don't need now. We don't really need this part here. We don't really need this part here. Because again, these statements are made true, like going this way and going this way, but keeping r greater than or equal to 0 by putting a stoppage there, and keeping r less than or equal to 4 by putting an endpoint here, gives us our final solution. So in solution set form, this one is probably the most confusing. Let's take a look. So r is in the set of numbers between 0 and 1 first. So we go 0 less than or equal to r less than 1. That's the first part. Or r is in the other solution set. 3 less than r less than or equal to 4. Your homework from this section is from 2.4 and then one review problem from 2.8.